So in this video, we're going to talk about how to solve rational equations with addition or subtraction. So here's what we're going to do to solve rational equations that require addition or subtraction. We're going to factor all the denominators in the equation, and then we're going to find the LCD, the least common denominator of all fractions on both sides of the equation, then multiply both sides of the equation by the least common denominator and simplify, and then we're going to solve the resulting equation and then check for extraneous solutions. So let's try solving this first equation. So what we're going to do is we're just going to start off by factoring all the denominators. So 2 is a whole number, so no denominator there. X plus 1 can't be factored. And then we have this x squared plus x. So notice that x squared plus x can be factored using a GCF. The GCF is x. So we're going to factor out that x, and then we're going to do x squared over x plus x over x. So when we do that, we get x times x squared over x is x, and then plus x over x is 1. So that's going to be x times x plus 1. So now we have 2 minus 1 over x plus 1 equals 1 over x times x plus 1. So now we're going to find the LCD, the least common denominator. So we have an x plus 1 factor, and we also have a factor of x. We don't need to write the x plus 1 again because that's already been included in our LCD. So what we're going to do is we're going to take this x times x plus 1 and we're going to multiply every single rational expression in our equation by this least common denominator. So what I'm going to do is I'm going to multiply x times x plus 1 times 2, right? And then that x times x plus 1 is going to multiply 1 over x plus 1. And that equals, over here, I'm also going to multiply that x times x plus 1 times 1 over x times x plus 1. So what's going to happen here is I'm going to multiply, I'm going to cancel common factors, do all the things that we normally do. So the first term, that's going to be 2x times x plus 1. And then I have minus, okay, so in this second term right here, you can see that I have an x plus 1 up here and x plus 1 down here. So those two will cancel. So all I'm left with x times 1, well, that's just minus x, right? Because I have a minus sign here, and then I have my x times 1, so that's just x. So that equals, well, over here, I have an x up here, x down here that cancel. I have x plus 1 cancel, so that equals 1. So all of that whole rational equation has simplified now down to this. That's the reason we multiply by the LCD. So all I need to do now is distribute this 2x. So I get 2x squared, right? 2x times x is 2x squared, plus 2x times 1, so that's just 2x. And then I have minus x equals 1. So this 2x minus x, those are like terms, so let's go ahead and combine them. So we have 2x squared plus x, and that equals 1. So now we have a quadratic equation, right? We have 2x squared plus x equals 1. Remember that to solve a quadratic, we want to set it equal to 0. So we have ax squared plus bx plus c equals 0. So I'm going to set it equal to 0 by subtracting 1 from both sides. So I have 2x squared plus x minus 1 equals 0. So now you can solve this problem using 3 different methods, right? So when you have a quadratic and it's set equal to 0, you can solve it by graphing. You can use the quadratic formula, or you can solve by factoring. So if you try to solve by factoring, I'm going to use the AC method. So we do 2 times the value of c, so that's negative 2. So we need 2 factors that'll multiply to negative 2 that'll add to 1, right? Because b is 1. So my 2, I need a positive and a negative factor. b is positive, so I'm going to make my bigger factor positive. Well, the factors of 2 is prime, so the only factors are 2 and 1. So my bigger factor will be positive, smaller factor will be negative, and negative 1 plus 2 does in fact equal 1. So those are the factors that I'm going to be using. So I'm going to go ahead and factor this. So I have 2x squared plus 2x, and then minus 1x minus 1. That equals 0, right? So I just took this 1x and I expanded it out. I wrote it as a 2x minus 1x. So what we're going to do now is we're going to use factoring by grouping. So when we factor by grouping, I'm going to put my 2 terms into 2 groups, and then I'm going to put a plus sign in the middle, right? So I have 2x squared plus 2x plus negative 1x minus 1 equals 0. So now what I need to do is I need to look for the GCF of each group. Well, the first group, notice that I can factor out a 2x. So I'm going to divide these terms by 2x. And so when I do that, this is what I'm going to get. I have 2x times 2 and 2 cancel. X squared over x is just x, plus 2x over 2x is just going to be 1, right? Any number over itself just reduces to 1. So I'm going to go ahead and simplify that. And then we have the next set, we have negative 1x and negative 1. Well, I can factor a negative 1 out of both of these terms, right? That'll give me negative 1x over negative 1 minus 1 over negative 1. And so when I do that, I have minus 1 times negative 1 over negative 1 will just cancel, so I have x. And then minus 1 over negative 1, that's just going to turn into a plus 1. So this common factor of x plus 1, I can go ahead and pull that out. So I have x plus 1, and then I'm going to write whatever I have left, right? I have that 2x, and then I have minus 1. And that is equal to 0. So now to solve this, I need to set each factor equal to 0. So I have x plus 1 equals 0. And so that tells me that I have x equals negative 1. That is one of my solutions. And then I have 2x minus 1 equals 0. So I'm going to add 1 to both sides, which gives me 2x equals 1. Then I divide both sides by 2, which gives me x equals 1/2. So I have two solutions, but I need to make sure that they make sense in the context of my problem. Okay, so remember, the way to make sure that they make sense is to go and plug them back into the original problem. So I'm going to go back and recopy that problem. So I have 2 minus 1 over x plus 1 equals 1 over x squared plus x. Okay, so I'm going to plug in x equals negative 1 and x equals 1/2 to make sure that my solutions are valid. So I have 2 minus 1 over negative 1 plus 1 equals 1 over negative 1 squared plus negative 1. So I have 2 minus 1 over 0 equals 1 over 1 plus negative 1. So I have 2 minus 1 over 0 equals 1 over 0. So you can see already we have this big issue here. We have a 1 over 0, okay? So we can't do that. That is undefined. So x equals negative 1 is kind of like my nonsense solution. It's an extraneous solution, so don't include that in your final solution set, okay? So I'm going to go now and plug in 1/2. So I have 2 minus 1 over 1/2 plus 1 equals 1 over 1/2 squared plus 1/2. So I have 2 minus 1 over 1/2 plus 1, that's just going to be 3/2. And then that equals 1 over, let's see, 1/4 plus 1/2, right? So when we do that, we have 2 minus, okay, so that's 1 over 3 over 2. So I can just flip that. So that's going to be 2 minus 2/3 equals 1 over 1/4 plus 1/2. That is going to be 3/4. So when I do this, I have 2 minus 2/3. So that is basically the same. If I put that 2 over 3, like I get a common denominator, that's going to be 6 over 3. So I have 6 over 3 minus 2 over 3. And I'm checking if that equals here. I'm just going to take the reciprocal, right? Because 1 over 3 over 4 is 4 over 3. And this is telling me that 4 over 3 does equal 4 over 3, which just checks out. So x equals 1/2 is my only solution, okay? So be very careful that you're going back and plugging in and that you're checking for those extraneous solutions because they are there and you do have to watch out for them. So now let's try this problem. So we have, once again, several different rational expressions in this equation. So we're going to look for our LCD, right? We don't need to factor anything because x plus 2 doesn't factor, x minus 3 doesn't factor. So the LCD is just going to be the product of those two factors. It's going to be x plus 2 and x minus 3. So I'm going to multiply everything in this equation by that. So I have x plus 2 times x minus 3 times 1, and then plus x plus 2 times x minus 3 times 3 over x plus 2 equals x plus 2 times x minus 3 times x minus 2 over x minus 3. Okay, so let's work this out and see what we can cancel. So we have x plus 2 times x minus 3, and then plus, here we have an x plus 2 up here and x plus 2 down here that can cancel. So I have 3 times x minus 3, and that equals the x minus 3 and x minus 3 can cancel over here. So I have x plus 2 times x minus 2. So x plus 2 times x minus 3, let's go ahead and use FOIL. So x times x is x squared. X times negative 3 is negative 3x. 2 times x is going to be plus 2x. 2 times minus 3 is going to be minus 6. Now we have a 3 times x minus 3 that we're going to distribute. So we have 3x minus 9. And then here, this x plus 2, x minus 2, you may recognize that. That is the difference of two squares. So that's going to be x squared minus 4. If you want, you can FOIL it out, but you'll see you get the same answer. So now let's go ahead and collect our terms. So we have x squared minus 3x plus 2x is going to be minus 1x. Minus 6 plus 3x minus 9 equals x squared minus 4. And let's see, we have an x squared minus x. And then I'm going to move this plus 3x over here. And then we have a minus 6 minus 9 equals x squared minus 4. So let's simplify this. We have x squared minus 3x plus, minus x plus 3x is going to be plus 2x. Minus 6 minus 9 is going to be minus 15. And that equals x squared minus 4. So we have now x squared plus 2x minus 15 equals x squared minus 4, right? Which was what we had in our problem. Let's move everything to one side now and see what we have. So I'm going to subtract x squared from both sides, which is going to cause these x squareds to cancel out. So I have 2x minus 15 equals negative 4. So now I can solve this equation for x by adding 15 to both sides. And when I do that, I get 2x equals 15 minus 4, which is 11. And then 2x divided by 2, and then 11 divided by 2 gives me x equals 11 over 2, which if you prefer a decimal, I know some of you like the decimals, you can say x equals 5.5. Remember, we want to go back to our original problem and plug it in to make sure that it is a sensible solution. So we have 1 plus 3 over x plus 2 equals x minus 2 over x minus 3. So let's plug in 5.5 and see what happens. We have 1 plus 3 over 5.5 plus 2 equals 5.5 minus 2 over 5.5 minus 3. So we have 1 plus 3 over 7.5 equals 5.5 minus 2 is 3.5. And then 5.5 minus 3 is 2.5. So we have 1 plus 3 divided by 7.5. So 3 divided by 7.5 is going to be 0.4. So 1 plus 0.4. And then on the right side, we have 3.5 divided by 2.5, which is 1.4. And it does work out, right? 1.4 equals 1.4. So we are good, and our solution is valid. Okay, so now you can go ahead and pause the video and try an example on your own. So in this case, our LCD is going to be, once again, just the product of the denominators, x plus 1 times x plus 8. So I'm going to multiply every single term in this equation by that x plus 1 times x plus 8. So the first term, we get x plus 1 times x plus 8. Next term, we have 6 times x plus 8. And then we have x plus 1 times x plus 5 on the right. So you need to FOIL whenever you have those two binomials, right? So we have x squared plus 8x plus 1x plus 8. Then we have plus 6x plus 48 equals x squared plus 5x plus 1x plus 5. So now we combine our like terms and simplify things, and we get x squared plus 15x plus 56 equals x squared plus 6x plus 5. So we need to now simplify and solve our equations. So we're going to subtract x squared from both sides, which gives us 15x plus 56 equals 6x plus 5. Subtract 6x from both sides. And then when we do that, we get 9x plus 56 equals 5. Subtract 56 from both sides, which gives us 9x equals negative 51. Divide both sides by 9, and so we can reduce that fraction. Both of these are divisible by 3. So that's how we get that 17 over 3. Okay, so negative 17 over 3 is the answer. We always want to go back and check. So we have 1 plus 6 over x plus 1 equals x plus 5 over x plus 8. So we are going to plug in and make sure that our answer is valid. Okay, so 6 over negative 17 over 3 plus 1 equals negative 17 over 3 plus 5 over negative 17 over 3 plus 8. So I'm going to do this, I'm going to do a lot of this in my calculator. So I do 6 divided by negative 17 over 3 plus 1. And that gives me negative 9 over 7. And then on the right side, I have negative 17 over 3 plus 5, which is negative 2 over 3. And that's over negative 17 over 3 plus 8. And that is 7 over 3. So we have 1 plus negative 9 over 7. So 1 is just, remember, negative, it's just going to be 7 over 7. So when you add them together, we get negative 2 over 7. And then on the right side, I'm just going to, multiply by the reciprocal. So that is going to end up, the 3's cancel, and that gives me negative 2 over 7. So this tells me that negative 2 over 7 does equal negative 2 over 7. So negative 17 over 3 is a valid solution. So let's try now this problem. Let's go ahead and solve this for x. So we want to factor all the denominators, okay? So it won't always be the situation where the denominators are already factored, but that's okay because we can factor them. So the only denominator that needs to be factored is this one right here. So that x squared minus 9. Notice that that is x squared minus 3 squared. Okay, so that's going to be x plus 3 times x minus 3. So I'm going to write this as 3 over x minus 3 plus 18x over x minus 3 times x plus 3. And that equals 9 over x plus 3. So now if I find the LCD, okay, so for the first denominator, I have a factor of x minus 3. So x minus 3 I already wrote, so I'm going to pick up this factor of x plus 3 from the second denominator. And then over here, I have an x plus 3, but I already have that in my LCD. So now I'm going to go through and multiply every single term by this LCD. So I have x minus 3 times x plus 3 times 3 over x minus 3 plus x minus 3 times x plus 3 times 18x over x minus 3 times x plus 3. And then that equals x minus 3 times x plus 3 times 9 over x plus 3. So now let's cancel our common factors. So we have an x minus 3 up here, x minus 3 down here. So that leaves us with 3 times x plus 3. And then now in the second term, let's see, we have an x minus 3 will cancel. X plus 3 cancel. So we have 18x, and then that equals, and then here we have an x plus 3 and x plus 3 cancel. So we have 9 times x minus 3. So now let's go ahead and distribute and simplify. So I'm going to distribute this 3. So I have 3x plus 9 plus 18x equals, I'm going to distribute this 9x minus 27. So on this left side, I'm going to combine my like terms. 3x plus 18x plus 9 equals 9x minus 27. So that is going to become 21x plus 9 equals 9x minus 27. I'm going to subtract 9x from both sides. And when I do that, I get 12x plus 9 equals negative 27. Now to solve, I'm going to subtract 9 from both sides, which gives me 12x equals negative 36. And then I divide both sides by 12, which gives me x equals negative 3. So that is the solution that I found, but I need to make sure that it makes sense in the context of the problem. Well, if I go back and plug it in, I have 3 over x minus 3 plus 18x over x minus 3 times x plus 3 equals 9 over x plus 3. If I plug in negative 3, I get 3 over negative 3 minus negative 3 plus 18 times negative 3 over negative 3 minus 3 times negative 3 plus 3. And that equals 9 over negative 3 plus 3. So that gives me 3 over negative 6 plus negative 54 over negative 6 times 0 equals 9 over 0. So you can already see here we have a problem. We have this 9 over 0, which is undefined, right? And this is going to tell me negative 3 over 6 plus negative 54 over 0, so another over 0. So that is not going to work, okay? So we actually have no solution to this rational equation, okay? Even if you only find one solution and that solution doesn't work, you have to say there's no solution. So now you can go ahead and pause the video and try this example on your own. So when we do this, we're going to look for the LCD. So we have in this first rational expression, we need to factor it. This is the difference of two squares. So this is going to be x plus 1 times x minus 1. So we're going to go ahead and rewrite this as x plus 1 times x minus 1 minus 4 over x plus 1 equals 4 over x minus 1. So what we're going to do is we're going to multiply every single term in this equation by that LCD. So we have x plus 1 times x minus 1 times 6 over x plus 1 times x minus 1, and then minus x plus 1 times x minus 1 times 4 over x plus 1 equals x plus 1 times x minus 1 times 4 over x minus 1. Okay, so let's cancel our common factors. So these two will cancel, leaving us with just 6. And then we have minus, so x plus 1 and x plus 1 cancel. So we have 4 times x minus 1. And then that equals, well here, the x minus 1 cancel. So we have 4 times x plus 1. So now let's go ahead and distribute. So we have 6. I'm just going to distribute that as though it's a negative 4. So I'm going to turn this into 6 plus negative 4 times x minus 1 equals 4x plus 1. So when I distribute, I have 6 plus negative 4 times x minus 1 equals 4 times x plus 1. So let me do all this distributing. So I have 6 minus 4x plus 4 equals 4x plus 4. Here I'm going to combine that 6 and 4 because they are like terms. So I have 6 and 4, which is 10. 10 minus 4x equals 4x plus 4. I'm going to move all my variables to one side. So I'm going to go ahead and subtract 4x from both sides. So that gives me 10 minus 8x equals 4. I'm going to subtract 10 from both sides. And so that gives me negative 8x equals negative 6. If I divide both sides by negative 8, that gives me x equals 3 over 4. So remember, before I say that's the solution, I need to go back and check. So I have 6 over, and I'm going to do 3/4 squared minus 1. And then minus 4 over 3 over 4 plus 1. And then that equals 4 over 3 over 4 minus 1. Okay, so let's go ahead and simplify all of this. So we have 3/4 squared minus 1, and then we do 6 divided by that. So we have, let's see, negative, let's see, 0.75 squared. So 6 over negative 7 over 16 minus 4 over, let's see, this is going to be like 4 over 4 plus 3 over 4, right? So that's 7 over 4, and that equals 4. And let's see, we have 3/4 minus 1, so that's going to be negative 1/4. So here we're going to flip and multiply, so we have negative 96 over 7 minus, here we also flip and multiply, so we have 16 over 7. Here we flip and multiply, so we have 4 times negative 4, so that's going to be negative 16. So negative 96 minus 16 is negative 112 over 7, and we're checking if that equals negative 16, and that does in fact equal negative 16. So our answer is correct. X equals 3 over 4 is the solution to this rational equation. So remember, to solve rational equations, you're going to factor all the denominators in the equation. Find the LCD of all fractions on both sides of the equation, then multiply both sides of the equation by the LCD and simplify. Once you do that, you're going to go ahead and solve the resulting equation and then check for extraneous solutions.